Hi everyone, welcome to AI Crack channel. This is Akash Kumar and today we'll be studying PnC Lecture 3. So we'll be talking about circular permutations and groupings in this lecture. So let's start with the circular permutations and we'll have two cases over here. The first case is circular permutations in which clockwise and anti-clockwise arrangements give rise to different permutations. So basically if we arrange in this manner or arrange in them in this manner, then they'll be giving different kind of arrangements. But there will be certain cases where regardless of in what way you are arranging them, they are going to give the same arrangements, okay? Practically same arrangements based on the utility. So let us try to understand the first part, that is A part. And before that, let's try to derive a general formula and how to analyze the situation of circular permutations. Analyze a box or a particular room which is closed from everywhere. There is no gate and nothing, no window, no gate. Everything is being painted exactly the same, and you cannot differentiate which wall is northern wall, which wall is southern wall. So basically, everything is very ideal over there, right? And there is a table over there, round table over there, and there are identical chairs placed around it. Okay. Now you have somehow you have been thrown inside that particular room, and now you have and you and your friends. Okay, let's say there are three friends. You have been thrown in that particular room, and now you have to sit around this circular table, right? Now, how would you arrange yourself? Usually when we sit somewhere, let's say if I am going for a roundtable conference or a meeting, then I have certain kind of notions on where I'll be sitting. If that is my favorite chair, if that location is closer to screen, if I'm nearer to my boss or not. So basically I have certain kind of framework or a benchmark based on which I am selecting a particular position. So I have a particular reference based on which I am selecting a particular position in that particular room. Although chairs might look identical, but still I have some kind of framework, some kind of benchmark or reference based on which I can choose a particular position, right? This is the normal case. But in this ideal case, you don't have any such reference. You don't have any idea of the direction. You don't have any kind of screen or door or window or any boss over there, and you just have to sit over there. Now imagine yourself there, and that would make you think that okay, this chair is exactly, this location is exactly same as this one. Regardless of whatever you, wherever you sit, it's going to feel same everywhere, right? Now let's say there are three friends over here, A, B, and C. Now you are sitting over here. Now you made a choice that I'll be sitting over here. Now this person is having a reference that okay, this person is sitting over here, so I can sit maybe over here opposite to him. Again, this person will have a reference. Basically, after a person sits, the other person will have the reference where to sit and where not to sit, right? Based on your location. Now, similarly, if let's say you decided to sit over here, right? This is the same room, but a different condition, but a different case, not condition, different case. Let's say in this case, you decide to sit over here, A, B, C, and now your friends are sitting according to you. But now over here, in this case, you are sitting over here, right? Over on this location. Now your friends would be sitting accordingly. Like this is B, not D. So this friend is sitting according to your situation, opposite to you. But since we don't have any kind of direction idea over here, this arrangement would exactly be the same as this arrangement because we don't really know what kind of direction we are sitting in. This person, this B person is making judgment of sitting according to your case. That is the person A over here as well and over here as well. And the A person is not having any kind of judgment for the direction, right? So this seating arrangement is exactly same as this seating arrangement. So why am I discussing all these things? So let us try to write the formula and then you'll get why am I discussing this particular thing in detail. In case of linear arrangement, let's say we had these four positions over here and we had to make four people sit in these four positions. Then we used to do 4 factorial, right? Based on the gap method or the permutations method. But in this case, let's say we have 1, 2, 3, 4, 5, and 6 positions. And if you have to fill these 6 positions with 6 persons, 6 different persons, it won't be 6 factorial. It won't be 6 factorial. It would be 6 minus 1 factorial. Why? Because the first person who sits over there now works as as a reference over there, and now the other persons can sit accordingly. So 1, 2, 3, 4, 5. These 5 people can sit according to this person's reference. So that is why 5 factorial. So that is why that ideal condition box is so important because we assume that everything being in ideal condition. If we actually have the sense of north or south direction, then definitely 6 factorial would be the answer. Let's say in the question they have given that, okay, the person who's sitting first is having the north and south idea, or basically there is a screen over there. Basically this person can make a difference. It's a TV over here, it's a screen over here, or there's a door over here. So this person can make the judgment now. But in case of an ideal condition, which is the usual case of every question, we'll be doing 5 factorial, 6 minus 1 factorial. But in case there is a specific mention of a door or a gate or a screen or anything else which can give us a sense of direction, we'll be using 6 factorial only, right? But that is a difficult, that's a difficult case. They won't be asking such questions, but just in case, to have that clarity in your mind. Now let's talk about a second case, the circular permutations in which clockwise and anti-clockwise arrangements give same permutation. So what kind of case we can have over here? What kind of conditions or arrangements where we can have over here? Let's say the standard cases of necklace of beads. So beads are circular. Let's say we have this kind of a necklace or a bracelet made up of beads. So if you look at it from the front side, or if you look at it from the back side, it would look exactly the same or more or less similar. Basically here utility is to just wear it. If you are wearing it from the front side or from the back side, it's not going to matter, because utility is to just wear it. So it's going to be the same necklace or same bracelet regardless if you are wearing it from the front side or the back side. So in such a case, if you are arranging from here, if you are arranging from here, doesn't matter. It would look, if I'm arranging from here, basically if I'm arranging from here and I want to see this kind of arrangement, I'll just flip it over and I'll get this kind of arrangement. And same with this kind of arrangement, right? If I want to see this kind of arrangement and having this kind of arrangement, I'll just flip it over. Okay. So in that case, we'll be doing, let's say these beads are n minus 1 factorial divided by 2. So this is our formula, because we'll have repeated cases over here because of the flipping part. In case of a table, we cannot flip the table, right? We cannot see from underneath the table. We have to see from the top of the table the arrangements. So that is why over here we don't have n minus 1 factorial by 2. But in this case, we can see from the underneath or from the above. Basically, it's based on the utility. That's why n minus 1 factorial by 2. Now let's look at certain examples. In how many ways can 5 boys and 4 girls can sit on a circular table such that no 2 girls are together, or all girls are together? Girls G1 and G2 sit together, but not adjacent to G3. So we have B1, B2, B3, B4, and B5. We have G1, G2, G3, G4, right? So we have this kind of circular arrangement, circular table, right? Now, no 2 girls are together. So basically we have to fill them in between the boys. Basically we have to use the gap method over here. So before that, we'll have to place boys, right? So how can we place boys? So let's say this is B1, B2, B3, B4, and B5. So we have 1, 2, 3, 4, and 5 gaps over here. We have to fill these girls in these 5 gaps, right? And boys can start sitting, giving the reference to the girls, right? So someone has to start sitting, right? So let's say these are the boys over here. So they'll start sitting by 5 minus 1 factorial ways, right? Because of the circular permutations. Now they have made their position around the table. Now we can fill these girls over there. So that would be 5c4 into 4 factorial. This 4 factorial is important. We won't be doing 4 minus 1 because we already have the reference over here. So that's why 4 factorial. In case we were trying to start filling from the girls, but in this case we won't be, because we have to fill the girls in the gaps only. But just in case the question was reverse, girls were sitting first and boys had to be filled in those gaps. In that case, we would have made 4 minus 1 factorial, and we would have made the gap filling with the help of boys. But in this case, since girls have to sit in between boys so that they are not sitting together by any chance. So that is why we have to place the boys first, and after that we have to fill girls in these gaps, right? So 5 minus 1 factorial because of the referencing part, multiplied by 5c4 to select any four gaps out of these 5 gaps, and multiplied by 4 factorial, right? So this is how our first answer looks like. Now let us look at the second question. All girls are together. So again, we have this case B1, B2, B3, B4, and B5, and G1, G2, G3, and G4. So all these are sitting together. Okay, so we have 1, 2, 3, 4, 5, and 6. 6 entities are there, and we have to place them around a circular table. So we'll be doing that in 6 minus 1 factorial because of circular permutations. Also, these four girls can arrange themselves in 4 factorial ways. Why? Because it's not a circle, it's a linear arrangement, kind of linear arrangement, because then this end is not touching this end actually. So it's a linear kind of linear arrangement. If they sit like this or if they sit like this, it's going to be the same. So that is why 4 factorial, right? And also, even if in case it was a circular arrangement, then also, since we have made the references, we have made b1, b2, b3, b4, b5, 6, we have made them sit along with this entity, it would have been the same because we have made the reference earlier. So it's anyways going to be 4 factorial regardless if it's a circular arrangement or a linear arrangement, right? Now let us look at the third question. Girls G1 and G2 sit together but not adjacent to G3. So let's do it over here. So this is our arrangement and we have G1 and G2 together in G3 separate from G1 and G2, and the remaining ones are G4, B1, B2, B3, B4, B5. So these 6 entities can sit however they want, but these have to be filled between these gaps, right? So this is G4, B1, B2, B3, B4, and B5, right? So let's say G4 is somewhere over here. Okay. Now we have 1, 2, 3, 4, 5, and 6 gaps, right? So the B1, B2, B3, B4, B5, and G4 can arrange themselves in 6 minus 1 factorial ways because of circular permutations. Multiplied by, we have 6 gaps, 6 C2 filling basically both these entities G1, G2, and G3. And now they can also arrange themselves G1, G2 in 2 factorial ways. And also, both of them can also arrange themselves in 2 factorial ways. So this should be our answer. 6 minus 1 factorial multiplied by 62 into 2 factorial into 2 factorial. This for circular permutations, this for filling the gaps, this for the internal arrangement of G1, G2, and this is for G1, G2, and G3 as the entity arrangement of G1, G2, and G3 as the entities. Okay. Now let's look at this question. How many different necklaces can be made from 10 different beads such that 3 particular beads always come together? Okay. Now we'll be using that second case over here. So we have, let's say, B1, B2, B3, B4, B5, B6, B7, B8, B9, and B10. Now these 3 entities are staying together and these all are different. So basically they all are being placed differently, individually. So this is 1 and this is 7. So we have total 8 entities. So we can make them arrange in 8 minus 1 factorial by 2 because we have to form different necklaces. Regardless if we are looking from the front side or the back side, because they are made from beads, it's going to be the same necklace, right? Because of the utility part. Multiplied by 3 factorials because this separate entity can arrange themselves in 3 factorial ways. B1, B2, B3. So this should be our answer. Now let's look at this question. 8 people, including A and B, are to be seated around 2 identical tables, each having the capacity of 4. The number of seating arrangements so that A and B are not at the same table. So this is one table. This is one more table. So A and B are sitting over. They are not at the same table. Okay. Now we have total 8 people. So each having a capacity of 4. 1, 2, and 3. 1, 2, and 3. Now, since these people have been made to sit, now they'll act as a reference, right? This one is for sure sitting over here. This one is for sure sitting on the around this table. So these people now can be considered as a reference point. So the remaining 6 positions can be filled in 6 factorial ways. So that is as simple as that. So answer would be 720. This one, this one, this one, this one, this one, this one. These can be filled in any way because we have the reference. We won't be using the circular permutation formula over here because we have already set the reference, right? Now let us talk about the groups. And although we have already talked about groups indirectly in the selections part while doing the derivations of selections or while doing the questions of selections, but let's look at it formally now. And as of now, we are talking about unequal groups. Okay. So let's say I have 10 people in a particular team and I want to divide the team into two parts. The for the first group is having 6 members and the other group is having 4 members, and I just want to divide them. I'm not naming this particular group or naming this particular group. I'm not doing anything. I'm just separating 6 people and 4 people. That's it. That is what we mean by groups. We're not naming them. Okay. So what we'll be doing, we'll be selecting 10C6 and the remaining 4C4, right? Basically selecting 6 people out of 10 people multiplied by 4 people out of the remaining 4 people. That is how we are going to write it, right? That would become 10 factorial divided by 6 factorial, 4 factorial into 1. So this becomes actually 10 factorial divided by 6 factorial, 4 factorial. Now I can see that if I have to divide 10 people into these groups, what I'll be doing, dividing 10 factorial divide by these numbers only, 6 factorial, 4 factorial, right? Now let's say I want to do 3 factorial over here and 2 factorial, sorry, 2, 3 and 5, basically dividing in these 10 people into 3 groups of 2, 3 and 5. Okay. Now what I'll be doing, I'll be selecting 10C2 in 10C2 ways, in 8C3 ways, in 5C5 ways. So this is how our basic selection formula would look like, right? That would give me 10 factorial divided by 8 factorial, 2 factorial, multiplied by 8 factorial divided by 3 factorial, 5 factorial, multiplied by 1 only. So this 8 factorial get cancelled out. We get 10 factorial, 2 factorial, 3 factorial and 5 factorial. Again, we have got a similar formula like this one, 2, 2, 3, 3 factorial, 5 and 5 factorial. So from with the help of this kind of conclusion, we can derive that if I want to divide a group into two unequal groups, in that case, let's say I have a group of m plus n people, then what I'll be doing, I'll be dividing into two unequal groups of m and n, and the ways, number of ways would be m plus n factorial divided by m factorial n factorial. So this you have to remember. This was about unequal groups and not equal groups. Okay. Now let's talk about the equal groups. Now in case of equal grouping, let's say we have a team of 4 people, A, B, C, D and F. I want to divide them into two groups. So let's talk about one specific case. Let's say AB comes here and CD comes here. And in the another case, CD comes here and AB comes here. Now, as a matter of fact, as I have told earlier, these two groups are just the separation. They don't have any names. This team doesn't have any name. This team doesn't have any names. It's just the separation of teams. Okay. So in that case, this case and this case would be the same because we have divided ABCD into two parts, AB and CD, regardless if it's in there or if it's in there, right? So basically our cases are being repeated over here in case of just forming the groups, not naming them, just forming the groups. So in such a case, we'll have a certain modification in the formula that would be 4 factorial, 2 factorial, 2 factorial, and an additional 2 factorial because of these two cases. Let's say there was a different case where we had 6 people and we had to divide them into 3 equal parts, 2, 2, and 2. In that case, we would have done 6 factorial divided by 2 factorial, 2 factorial, 2 factorial, and 3 factorial because of these 3 equal teams, okay, similar teams. So this was all about the groupings, and let's look at one example. In how many ways can 8 distinct books be distributed among 3 students such that each student gets at least 2 books? Okay. So we have 8 books over here and every student is getting at least 2 books. So we can have groupings of 2, 2 or 4, or we can have 8 and we can have grouping of 2, 3 and 3. So these are the two possible cases for distributing 8 into 3 parts, right? For making 8 into 3 parts. Right? Now these are just the grouping. After that we have to distribute also. Okay. So for this kind of grouping, we'll be getting 8 factorial divided by 2 factorial, 2 factorial, 4 factorial. So this is how we have made the groups only. Now we have to distribute them among 3 people, 3 children into 3 factorial, right? Similarly over here, because of these 2 factorial, I forgot to multiply this 2 additional factorial over here. Similarly over here, it would be 8 factorial divided by 2 factorial, 3 factorial, 3 factorial, and an additional 2 factorial because of these and these, multiplied by 3 factorial because we have to distribute them among 3 students. Now we have made these cases and found out the grouping methods. We have to distribute them among 3 people, 3 different students. So today's lecture was till here only, and in the next lecture we'll be talking about certain advanced concepts. So let's meet tomorrow. Thanks for watching.